Okay, welcome everybody. I'm just going to do a quick presentation on an Emseal expansion joint solution. We were involved in the new Yankee Stadium. This is going to specifically talk about the 100-level seating bowl. It is the lowest bowl that wraps around the stadium, and it's made up a bunch of precast treads and risers. We were involved in this project from very early on. We were involved in the specification, and this is more about after the specification had already gone through, and we were just ready to proceed with the first order. So at the stadium, the Emseal Thermoflex TCR series was specified for the 100-level seating bowl. Basically, this expansion joint opening, as you can see in the schedule here, this is just a cut from it, was designed to be 3.5 inches at mean temperature, which implied we were going to use a TCR 500 at this location. When communicating with the contracting team in regard to the movement, they weren't able to provide any sort of movements on the system, as often happens late in the game. For whatever reason, possibly engineers are off the project, or that information is just hard to obtain. So we were basing all of our movement criteria based on just the specified system. This system had been specified. Let's just go with that. So early on in the project, we went down and visited this site. A lot of times on large projects, we like to do a meet and greet with the subcontracting team that we're going to be working with, just to lay down ground rules or some groundwork, just to ensure that we have a successful working relationship over the next year or so on a project of this scale. Upon initial inspection of the 100-level bowl, seating bowl, we were able to see that the gaps were a little bit wide. It seemed to be around 5 inches, close to mean temperature. So this was an issue that came out of this meet and greet. And so what we asked is, we asked the subcontractor go and measure all the expansion joints at the locations. Now this is a typical situation for when we're supplying expansion joints on a project of any sort of magnitude, but because there was some variance from the design gap width, it was really important that we measure the widths. Typically we want to know basically what the joint looks like in 3D and how it transitions. This was more of just measuring the width to see if the TCR system could even work in this application. Out of this, we designed the field joint size sheet, and the contractor basically used this sheet and went on each joint run. I know it's kind of hard to see here, but it says, it would say the column line, the location. So there were 5 column lines at that seating level bowl. He'd fill in the column line, the location, and then basically the different measurements with deck temperature. Now, measurements with temperature are very important, because a measurement without a temperature doesn't really tell us where we are in the basically the thermal cycle or the thermal spectrum that this joint will see throughout a year. So the temperature was very important. After we compiled all the data, it was sent via CD, and we looked at all the different measurements with the thermal considerations, and we coupled that with general rates of expansion and contraction on cured concrete. This is academic expansion rates of concrete, so they're very estimatory. And we coupled that with temperature highs and lows for the area, and that would help us to determine the maximum and minimum joint gap size relative to the temperature at the observed date. It was determined that the TCR 500 would not work at this location without validation by an engineer of record. Just based on standard expansion rates of concrete, it appeared that the movement range was going to be way outside of that of TCR 500. Seeing as though we're not licensed professional engineers and don't claim to be, we went back to the contractor, letting him know that an engineer of record should review this and help determine what system with our guidance would work in this location due to the new movement criteria because of the widened joint gaps. When we went back to the subcontractor with this, as oftentimes, as I said earlier, there is no engineer on the project, or an engineer was not able to give this judgment. Because of that, we were asked to provide a little bit more help, and this is where the difference of specifying Emseal comes into play. We developed a matrix here, and it basically talked about each location, what was specified, the minimum gap measured, and the maximum gap measured. As you can see here, we can just take the 9 line. It's the seating bowl, 100 level. It was designed at 3.5 inches. The pro system was TCR. The minimum measurement at this location was 5. The maximum was 5 1/16. So that's not a lot of variance. It still is much wider than this location. We basically estimated the anticipated movement range based on the historical data that we had found for the temperature highs and lows, and we gave a possible solution. In this location, there was some misalignment of precast panels, because not only did the contractor provide the joint gap widths with temperatures, he also provided photos, and we talked about possible remedies for substrates. So we could go with either a larger TCR or an SJS system, which is an entirely different system, which could likely better accommodate this location. So this is when you go with Emseal, you can be sure that, had we supplied the 3.5-inch material, it would not have worked in this location. It would have undoubtedly resulted in a leak. So this matrix was used by the general contractor to switch the material to SJS rather than fixing the field conditions. What they would have had to do was cut out the concrete edge, basically form the gaps at 3.5 inches at nominal temperature, ensuring that the concrete was structurally sound. And the labor involved in that was determined by the general contractor to be more than what it was worth. So basically we used a different system that had a larger movement range in these locations. We were on site to ensure that the system went in appropriately. And on other levels in this project, for example, the 150 level bowl, it also had joint gaps that were wider than originally specified. And this same matrix format was used to propose a solution to address these as-built conditions. So in closing here, the successful outcome could not have been possible without open lines of communication between the subcontractor and Emseal. So when Emseal is specified, we don't simply supply 3.5-inch material as it was specified. We look at each project and the as-built conditions to ensure that what we are selling is going to work and be 100% watertight in the application. So as the issue was observed, solution was proposed, and a watertight application was the outcome. And the 2009 World Series would have had leaky expansion joints had we not done our due diligence and ensured that the proper system was supplied for this location. Thank you very much.